I'm here with Farhad Hafezi. We're going to be talking about cross-linking, but in a little bit of a different way. You know, we generally, when we talk about cross-linking, we're talking about keratoconus, we're talking about post-LASIK complications. What is it that you're using cross-linking for?
Well, thank you, Josh. Indeed, we started cross-linking for keratoconus in Theo Seiler's group in 2000, but in 2008 we showed the proof of principle of something that I personally think will be much bigger than cross-linking for keratoconus, which is the use of cross-linking to kill microorganisms, so the use of cross-linking in infectious keratitis. The main concept behind it is taking cross-linking out of the niche of the rare disease keratoconus and bring it into one of the leading causes of blindness, which is infections of the corneal surface. We have given the proof of principle in 2008, where we showed in a small case series of the use of cross-linking using the basic Dresden protocol settings we applied in keratoconus before to treat advanced keratitis. And ever since, the field has been moving slowly but steadily. We have about a dozen publications out in the field now showing the use of this technology in infectious keratitis. What we of course need now is bigger study numbers and more basic research behind it.
Now, when you say that you started out with Dresden protocol treatment, have you modified that protocol specifically for targeting antibiosis as opposed to keratoconus?
Yes, absolutely. So what we have been doing is, on one hand, we started in collaboration with the Research Institute of Ophthalmology in Cairo, a prospective study on the use of cross-linking in infectious keratitis back in 2010. At that time, still using the Dresden protocol. We have treated now, we have a total of 40 eyes in that study, 20 controls that were treated with the maximum of what conventional therapy has to offer today, and the other 20 with conventional therapy plus cross-linking. This study is under peer review and should appear soon. Independently of that, at the University of Geneva in Switzerland, we have a research team of more than 10 people now, cell biologists, molecular biologists, that work on the basics of this phenomenon, and we've tried to optimize the parameters. On one hand, we are able now to we have on one hand optimized the beam profile of the cross-linking device to make the killing rate more efficient. And we are now able to kill 99.9%, which means a reduction of 2 log units of MRSA, methicillin-resistant Staph aureus, in as little as 150 seconds. So we can eradicate MRSA and Pseudomonas, and we are working on Fusarium and Candida on the fungal side in as little as 2.5 minutes. But this is not being done with riboflavin anymore, but with a new chromophore.
Really?
Which I cannot reveal yet because it's proprietary information under the umbrella of the University of Geneva. So we are working on a heavy modification of the technique that would allow us to act in developing countries where the general ophthalmologist is confronted to an advanced ulcer, knowing the patient will maybe not ever come back to his practice. The patient cannot afford conventional therapy easily. So we should be able to offer a method that helps him drastically reduce the number of bacteria in that cornea within a few minutes only.
If you have a cornea with a partial melt, so that you're concerned that the bed thickness is on the thinner side, can you still do this sort of treatment?
In the end, it's an assessment from case to case. In the very beginning, we were also, for ethical reasons, obliged to use far advanced keratitis cases. Our aim, of course, in the future is to treat as early as possible. But again, if you're confronted with a far advanced case, then I would simply make the assessment: what do I have to win? What do I have to lose?
Right, of course.
And I would, for the sake of calming down a cornea and getting it to a quiescent state that will allow me to avoid an emergency keratoplasty, in this case, I would be willing to sacrifice a portion of endothelium behind it, below the defect, knowing that the alternative would maybe be an emergency keratoplasty.
Right, of course. Now, do you have any sense of how this works? I mean, how the cross-linking kills the bacteria?
There is a number of proposed mechanisms. On one hand, cross-linking per se changes the tertiary structure of the collagen fibers, which means that collagenases, which are upregulated during any kind of melting, have a harder time to get to the cleavage site.
I understand.
So this is steric hindrance. Secondly, the combination of energy and a chromophore that takes the light and creates free radicals, creates reactive oxygen species, which would kill any cell membrane that is around, whether it's a keratocyte or pseudomonas. So it's a direct attack towards the cell membrane. Third, there might be an intercalating action between the chromophore and the DNA directly. So there is a number of mechanisms that might be used, and funnily the chemical industry uses riboflavin and UVA as a disinfectant for decades now.
It's really neat, and as a cornea person, I mean, this was certainly extremely promising stuff. Farhad, thank you very much for spending time with us today.
Thank you.